Okay. Hello, everyone. Welcome to the second workshop. Movement Boogaloo. That's a stupid joke. Today we are going over movement and frame rate independence and vectors and input and all the things that make your game interactive. So, first things, everyone should open the template project. If you haven't downloaded the template project, the link is in the Discord. Please do that as soon as possible, because we're going to be using that during the workshop. So this is what it should look like. If it doesn't look like this, you may need to go into scenes and open sample scene. But it should kind of look like this. Is anyone having any issues doing that? Yes? No? Okay. I'll wait a little bit for everyone to get that open. So, our first topic is transforms, and you may have heard this a couple times. I think we went over it a couple times last workshop. So what does transform mean? So transform is just the name of the component that kind of manages all of the physical dimensions of an object. It has three different parts, which is the position, where it is in space, rotation, how it's oriented, and scale, how big it is in relation to how big it is in code, basically. And each of those has three components of their own, an X, a Y, and a Z. And these should be pretty familiar if you've done any geometry or math or physics. We just use X for the horizontal, Y for the vertical, and in 2D, Z is away from the camera. So negative Z is towards the camera. For position, we don't use Z a lot in 2 dimensions, but we can use it for kind of reordering sprites. So if you want one sprite in front of another sprite, it would have a lower Z. And if you want something behind something, it would have a higher Z. Does anyone have any questions on that? So, quick note on the naming in scripts. The transform with a capital T is the type. So you would get get component capital transform. But with a lowercase t, it is the variable for the specific object's transform. So if you wanted to access that, it'd be transform dot whatever. And that's just your local objects thing. So these two things are equivalent. Get component transform is the same thing as lowercase transform. Some objects transform is the same thing as its get component transform. We're usually just going to be using the variable, which is lowercase. The uppercase is just for the type. So we can access or kind of manually manipulate the transform in the editor. It should be the first component in every game object, including the camera and our little sprite right here. It's right up here. So we've got its position. We can drag its X, and then we can drag its Y. If we drag the Z, it doesn't really do anything. Our rotation, the X kind of skews it. The Y kind of skews it as well. We're mainly going to be using Z for rotation, which kind of tilts it. And then its scale works the same way, just Y, all X and Y, and so on and so forth. And you can reset an object's transform by clicking on the little gear up here and clicking reset. I know some of you might be still opening the project, but yeah, you can just play around with that. Yeah. So our first function for kind of manipulating our transform is transform.translate. And this is our function for kind of moving any object. So it takes 3 arguments, an x, a y, and a z. All of them are floats. You don't have to give it a float, you can give it an integer, but it's going to be taken as a float. So I've kind of color coordinated all of the x, y, and z's in the slideshow because in Unity, if you manipulate something, you can see that it's kind of the z is blue, the x is red, and the y is green. So yeah, that's kind of the reason behind the colors. And so to use this in a script, you just give it how much you want to displace the object. So here, what this would do is it would displace it by 3 units. So basically add 3 units to its current position. Any questions on that? Okay. So your first challenge is to move an object. So I'm going to real quickly kind of show you how we're doing this. So in our little scene right here, how many of you don't have the scene open yet? Okay, so I'm going to probably give a little bit more time to this one first, but basically what we're going to be doing is this sprite right here automatically has a script attached to it. So just double click on the script in the assets, and you'll see that it already has some variables inside of it. We don't have to worry about those variables yet, but we're going to be using this script for these challenges. So your challenge is to move a sprite up 1 unit per frame and right 1 unit per frame, kind of at the same time. And this is your reference. So this is the function you're going to be using. And if you want to, if you get done with that and you're like, okay, I'm done, then you can also try out transform.rotate, which works basically in the same way. So yeah, call me over, or Wayne over to come and help you with anything. And yeah.
Is it just supposed to be like this? Because it just goes like that.
Yep. That's good.
Okay.
I don't think I'm doing this one. I just have it. Or I opened up the file from last. Is that what I was supposed to do?
No, you're supposed to clone.
Wow. Do you have it downloaded on the computer?
Yeah, you need to.
I do have it open.
Yeah, so you need to probably close out of that and open that scene in Unity. So close out of Unity. And then reopen it. And go to Open up here. And go to where you cloned it. It should be in Unity Desktop. Well, not Unity, GitHub Desktop. It should tell you. Go to the Unity Desktop application. Or wherever. How did you clone it? Yeah, GitHub Desktop. Okay. So go to right here. Yeah. No. Yeah. Click on that. Okay, so that's in C users. IMA. So I'll go that. It's in C users. So it's in your documents. So if you go to Open, GitHub Product Workshop, and yeah, you should be able just slightly slower.
Yeah. Did you get it? Want me to hold it?
Anyone want help? Can you put it in start?
Oh, you don't need to write float because you defined it.
So-
Oh, you did it.
Or it's already like automatically. So just write the number and it acknowledges.
Okay, so once this is, okay, so here, you have to open the scene. I don't know, it doesn't auto open.
It's frozen.
Yeah. So everyone, if you don't have this Unity logo in the middle of your screen, you need to go into Scenes and double click on Sample Scene because it might not have auto opened the scene. So yeah, just do that. Yeah, just wait for a bit, but once you can get it to kind of respond, just go into Scenes and then double click. Yeah, there you go. Yep. So go into Unity. Do you have the console up here? So it tells you on line 18. Okay, so that's something that I need to kind of mention. You don't need these floats, you just need the raw number 1. Oh. Yeah. Yeah. So everyone, when you're implementing this function, you don't need the float keyword. That's just me telling you that the type of number that it's expecting is a float. You just put in a single number and you're good. You can put in 0 if you don't want anything, and you can put in 1 if you do want something. Or, whatever. Just some number. Yep. So the start is going to run once when the game first starts, and update's going to run once per frame. Does that answer it? Okay. Cool. Anyone else having issues? Sorry. How many of you are not yet done? Okay, I'm gonna. Once again, if you are done with the translate, you can also try to play around with transform.rotate and kind of see how that works. Raise your hand again if you're not done. Okay, so I'm going to move on. So the answer is just in update, put transform dot translate 1 1 0. So I'm just going to go ahead and kind of do that. So and as many of you may have noted, when you hit play, it should just run off the screen very quickly. And we will be addressing that in the near future. Does anyone have any questions about that exercise, like anything that didn't work? Yes? Oh,
I tried to put in a decimal value for this because I thought it would make it slower, but it wouldn't let me do that.
You have to specify an F after the number. Yeah.
So Unity is kind of finicky about its floats. So there's two types of decimal values. There's a float and a double. Double is double precision. You can get more decimals out of a double. Most of these functions only accept floats. So if you have a float that you want to give it, you have to specify like just a lowercase f right after the thing. So if I wanted to make this, say, 0.1, I would have to give it an f. And if I go here, yep, then, yep.
Okay.
Cool. Any other questions? You had a question?
Just the same one.
Okay. Okay. Moving on. So now we're getting into input. We're actually going to be making games. So the way to use get input from the player, that is to get the mouse keys or like the keyboard inputs or gamepad inputs, is something called the input manager. The input manager is part of the editor. So you access the input manager by going to Edit, Project Settings, Input. And it should be kind of where the inspector is. I can kind of demo that right now. Edit, Project Settings, Input. And drop down the axes, and you should see a list of what is called buttons or axes. So each of these is kind of a button and kind of an axis. So if you, here, going back a little bit, the plus side of having this big input manager that you have to kind of go through is that you can have a button in the script. Say you want a button for firing a weapon. Then you can rebind that to whatever key on the keyboard, and you can pass that rebindability to your users. So say they have a different keyboard layout and they want to have kind of a more accessible thing, then they can rebind it to whatever. This really beats out just kind of looking for a specific key or a specific button on a specific gamepad because of that rebindability. Also, same thing with gamepads. You can have gamepad support very easily without changing any of your code. And it has kind of joystick axis support. So to add a new button, you just kind of add a 1 to whatever is in that size field. So I would just kind of make this 19. And it kind of duplicates the end one. And so I can rebind this to say like duck or whatever. And then it's got all these different things. So you can have buttons, and there's a lot of different ways to kind of input these buttons. Probably what you want to do is look up on the Unity documentation all the names of all the buttons. We can link that in the slideshow. But yeah, there's like a ton, and they're hard to memorize. So how do we use these in scripts? And the answer is with input.getButton, or getButtonDown, or getButtonUp. And then you pass it a string, which is just, a word. And that string corresponds with the button's name. And so, for example, we have jump. If you wanted to access that, you would, in your code, do input.getButtonDown jump. And then that would kind of send a true. And these are kind of meant to go with if statements. So say in your code, if you wanted to have a certain piece of code run when a user pressed that button, then you would have if get button down jump, and then your curly braces, and that would, inside of those curly braces, you would have your code. And so there are slight differences between these three functions. The first one is get button down. This only returns true for one frame, and that is when the user first pushes it down. So if they hold it down, the code inside of that if statement's only going to be running once. Then the second one, get button, is going to return true for the entirety of the duration that the button is pushed down. So if, say, you wanted to have the player move to the right when a certain button is pushed, you would use get button, and the code to move the player right would be executing every time as long as the button is held down. And then the last one is get button up. Same thing as down, but when the user lets go of the button, then it's going to return true. Any questions on any of that? I'll have kind of a little demo here soon. Right now, actually. So, say in update, we have debug.log get button. Yep, get button down. Say horizontal. No, jump. So, if we go ahead and run this in Unity, we can see it's outputting false every frame until I hit the spacebar. Maybe. Oh yeah, it is.
You need to click on the game first.
Oh right, yeah. Okay. So now I don't know if you can see that there's kind of trues interspersed in there. So if we change this instead to if input dot get button down and you don't have to be copying this. This is just kind of a demonstration, but you can if you want to. Jump. Jump. Then we can say just like jump. So now inside of that if statement, every time we press the space button, it's going to do that. And then we can change that to get button instead of get button down. Can anyone tell me what that's going to do?
For as long as you have the button held down, it'll print that.
Yep. So just go back here. Jump, jump, yep. And so on. Does that make sense? Cool. So the next thing we have is axes, not axes. Stupid joke. So does everyone know what I mean when I say an axis? So an axis is basically a range between -1 and 1. And you use these for joystick, or gamepad joysticks. So say you pushed you had the left joystick kind of pushing to the left, then it would be -1 in the axis. And then if you pushed it to the right, it's going to be 1 in the axis. And so any kind of value in between is going to be, say, like 0.75, -0.45, or whatever. So we can use axes to kind of have cleaner movement code. So we have, if we want to have an axis for buttons, then we have a negative button, which would kind of output a -1 whenever it's pressed, and a positive button, which would output a +1 whenever it's pressed. kind of explained right there. And we could also have it be like an actual physical joystick axis, but since we don't have any joysticks here, we have to kind of use these positive and negative buttons. And then the two functions we have to get these in code are input.getAxis and input.getAxis raw. You kind of pass it the name as well, kind of exactly the same as getButton. But instead of returning a true or a false, it's going to be returning a value between -1 and 1. The difference between getAxis and getAxis raw is that if you use getAxis, then it's going to kind of not be entirely representative of your axis. So if you push the positive button, the value is going to start moving towards 1, but it's not going to be immediate. So your character is going to kind of accelerate towards their full speed, but not quite be immediately there. That's what getAxis raw is for. That is a direct representation of your axis. So as soon as you push the button down, it's going to be 1. Yeah. Does anyone have any questions on that? Okay. So we can use this with our little debug.log example. So if we debug.log input.getAxis horizontal, and we can go and see which buttons correspond to that horizontal axis inside the input manager. So if we go into horizontal, we can see that the negative button is left and the positive button is right. We have alternative buttons for A and D, which is what I'm going to be using. So if we go ahead and play this, you see it's 0 when I'm not pressing anything. I'm pressing A now, and you can see it kind of goes through all the different values in between before it gets to -1 or 0 when I let go of it. And then if I hit D, it's going to go to 1. Does that make sense to everyone? Let me do getAxis raw now. No. What does it want me to do? Raw. There we go. Okay. So raw is not all capitals. It's just raw. So doing that again. So now you can see it's not going through any of the buttons in between. It's just -1, 0, and 1. And again, that's really useful if you want like really instantaneous input and not have any kind of smoothing or interpolation on your input, and you want to use an axis. So, yeah. So for your next challenge, we are going to be using input and translate. So what you're going to do is you're going to translate the Unity logo up and down, and left and right if you can or want to, using either getAxis or getAxis raw. And you're also going to be rotating the Unity logo when you press a button. So the script is kind of already set up to do this. So we have 3 string variables right here. We have horizontal, vertical, and jump. So instead of giving it like a kind of direct string, we can just give it horizontal axis name, and that's going to be getting the horizontal axis. So you should use those 3 axes It's going to be WASD for the horizontal and vertical, and it's going to be space for the jump. Any questions on how to do that? It's going to be kind of a longer challenge. OK, let's get to it. Just raise your hand if you have an issue.
I get the idea about using the function and stuff too. Like, how would I make it? So, because right now I have this part, and then I'm only moving it forward. But how would I make it to like tell that?
So you know that so for the translation, we are, instead of using the get button, we're using the get axis.
Oh.
And you know that get axis is a value from -1 to 1. So if you use that value, or no, so you need to somehow get the output of this into the funding of that. Oh, okay. Yeah. Does that make sense?
Yeah. Wait, so for here I would put like get button, and then inside here I would put get axis.
So I'm just going to say that we don't need a get statement here. So since this is outputting 0, when you're not
Did your get access work?
then
Did your get access
you
work?
have it running
Get
through frames.
access.
It's not doing anything when you're
Isn't that the one we use for like moving the
Oh, yeah,
Okay.
yeah.
So
Because whenever I put it into this stable one, it always just returns with an error right there.
Personally, I feel like you can use that as much more.
Okay. So you can use that with a variable, or you can
Sure. So get access. What does get access return? It's
Anyone
a float,
else
right?
needing help?
Oh, yeah.
So you need to use a different function, which is
the get button.
right? And that's the one that returns the bool to determine whether the button is down or not.
Oh, okay.
Yeah, so that's actually an expected behavior, and we're going to get into that.
So I got it working,
Mhm.
but I'm curious. When I rotate it all the way, the left and right is like switch
Yep.
the axes.
Yeah,
is like
so
flipped.
that's actually an expected behavior, and we're getting into that a little bit later.
Okay.
So I'm just going to say translates it in relation to its rotation.
Right.
So forward is actually changing when you rotate the object.
Right. Yeah.
Yeah.
That's what I'm saying. Okay.
Yeah. Anyone else needing any help?
I'm
Yes. Okay.
Wait, a little right. Let me see. Maybe it's, is it the?
So what you're doing?
I don't know maybe, but Joel has some other things.
Once
So
once the get button down is true, you're moving it just by one.
So I like
So do I have to assign like a negative?
I want to go down to
What I would, yeah, correct, you need both a negative and a positive value, but you can get that with your get,
I know I'm messing
with your input get
because
axis
I know it's just rotating no matter
raw,
I guess.
right? Because that returns whether it's an A or a D, the negative,
you can also use
or
these variables.
the negative button or the positive
Oh, so
button.
you can.
So you can't just put just the one there, right?
As well,
Yeah.
if you want to.
So what you're doing here is if the bottom is pressed down, right?
Anyone else have questions?
So you need to include
For the left and right,
Let me move it.
Okay,
So I'm going to say no is an if statement for
translation your number from
because
this one.
do you-
know that
do you get what I mean?
the axis
Or-
outputs a value from -1 to 1.
Wait, so
So
what was it?
0.
So
Can I see your explain?
yeah.
So it's different to get translated based on the
Don't bother with the velocity stuff. I was just like,
If you use get access,
pressing the button.
right.
So there's no need for an if statement.
Start from 0 and go to
That
+1.
So this should work really good.
Point one, point two.
Does that make
So
sense?
it doesn't have to be wrong.
Well, you can try get access, but if you remember, get access also includes the intermediate values between 0 and 1, for example. So get access raw just immediately says 1 or -1 for 0. So
But either of them should work.
either of them should work, yeah. So get access will give you like somewhat of an acceleration.
So will this work itself or will also?
Yeah. Like if I just
Anyone else?
So this way. So if you save for now, and you go hold down
So-
and you click play.
there.
Put your
So it's like gradual.
Is it supposed to keep
So it's gonna be but not equal 0.
Well, you should probably use get button instead.
That's
Get
the
button for when the returns
So just know that if you press it goes from 1
Yeah,
to
you
1
can
to
do that
so
that way.
it's not
Right.
not equal to 0.
Are you able to input gate access into the form, like the X, Y, Z?
Yeah.
Okay.
So we're getting the access to, if you don't press the actual, it will give you there.
Right, so I don't need this.
So when you press A,
Only the axis bottom. Here's the bottom one.
So the input of the axis wall is not.
Okay, so if I'm not holding it down,
I think so.
then I don't have to worry about it. I will run.
So for the translation,
I never got to. I left
the rotation you
a bracket.
translation you I think it'd be better if I use to actually.
My bad.
Yes, and you can either do that with the variable or just the close functions.
Oh, it's so you're just missing a different the other parameters. So translate takes a factor 3, so you need 2 other values.
Is it just 0?
Yeah, they're just gonna be zeros. Yeah.
So raise
this
your
one-
hand if you're
yeah,
done.
and then the other one you have to have.
You're done?
Yeah,
You're done?
because that's the X, right?
Okay, so
And
we're
you
kind
need-
of getting
Yeah.
a little bit over time. So I'm going to go ahead and kind of show the finished product. Unfortunately, if you didn't get finished, then you can see what the final product is on the slideshow. So this is kind of an example of what it could look like. So our first line is transform.translate, and then our getAccess function. And so you know that the getAccess function is going to output basically anywhere from -1 to 1. And if we put that directly into our translate function, then we're going to be translating every frame the output of getAccess, and that gives us our desired thing. The next line is basically the same thing, except for the vertical axis instead of the horizontal axis. And we're putting 0 in wherever we don't want to translate. And then our final thing is a if statement block in which if the input.getButton, rotate button name, which is basically if you press jump, then it's going to rotate in the Z direction. You can rotate it however you want. You don't have to do that, but yeah, that's basically how it's going to go. So if I kind of put that here. Oh no, we don't really have time to kind of. Might be able to just. Paste this in. So the expected behavior should be something like this. And then when you press space, it does that. So you might have noticed that your translation kind of doesn't make sense anymore once you've rotated. And that's a product of transform.translate being in relation to your current rotation. So whenever you rotate an object, its forward direction changes. And if we're translating it in the forward direction, which is basically the y positive, then that's going to be changing as you rotate. Oh, that's not it. So we're going to be finishing up soon, but I kind of want to get through frame rate independence really quickly. So I believe I explained this a little bit last time, but basically, so to understand frame rate independence, we need to know what a frame is. A frame is just a single image that was displayed on the screen. And games render a lot of these frames in order to make the kind of illusion of motion, or the illusion of motion. So games will commonly run anywhere between 30 and 144 frames per second. And most of the time they're going to run at 60 or up. If you have an uncapped frame rate, then there's no real upper bound on how fast the game can run. So you might remember that update runs once every frame, which means if we're doing motion inside of update, then if we're translating 1 unit per frame, that's the actual effective speed of our motion is going to depend on the user's frame rate. This is kind of a really bad practice, because if you have someone running it on, say, like a phone, they're going to have a much lower frame rate than someone running it on, say, a computer. So 30 units per second, so if we're using 1 unit per frame, 30 units per second is at 30 frames per second, and it's going to be 300 units per second at 300 frames per second. And that's a very, very large difference. And 300 frames per second is actually very possible. So in order to solve this, we can use math. So there is a variable which is accessible to all scripts called Time.deltaTime. And basically the concept of Time.deltaTime is if you multiply it by your current frames per second, you get 1 second. In other words, this is the time it took to render the previous frame. So we can actually use this to translate or transform our units per frame into units per second. So if we multiply our velocity or our speed times Time.deltaTime, then we actually get our speed in units per second instead of units per frame. So that was a lot of information. Does anyone have any questions on what I just said? Yes?
I'm just curious, have like developers ever avoided having to do that by just locking the game to like 6
Absolutely. So there was a game called, recently I think it was Need for Speed Most Wanted or something like that, that had frame rate dependent movement. Also, Dark Souls 1 on the PC has frame dependent movement. So if your game slows down, say past like 45 frames per second, then the actual game speed slows down, which is an awful thing. So we want to avoid that as best as possible. And the easiest way to do that is to just multiply our speed by Time.deltaTime. Any other questions on that? Okay. So we can use this for our translation function by just having a speed, an axis, and the Time.deltaTime. And for our x, we can have the horizontal axis times our speed, which is 5, and our time, which is the time that it took to render the last frame. And that's going to be, when you're pressing the horizontal key, you're going to be going at 5 units per second. And the reason we're multiplying it by our axis output is because that way we don't need an if statement to tell whether we're going left or right. Because if we have our negative button pushed, then the translation is going to be to the left because it's going to be negative. If we're going to the right, then it's going to be positive because it's just multiplying by 1. Does that make sense? And yeah, I know we're kind of going a little bit over time. So we had a challenge here. We're not going to do that. And we will probably have to get to vectors next time, unfortunately. So yeah. So does anyone have any final questions, like on the challenges that you did, or frame rate independence. I know you didn't get to chance to practice it, but yeah.
So for get access, is there a way to make it less or more sensitive?
Yes, and you can do that with the input manager. So you can see that we have a bunch of properties here, and there are 3 related to the sensitivity of get access. We have gravity, dead zone, and sensitivity. So gravity is basically going to be your acceleration. Your sensitivity has to do, I believe, with your axis, your actual pad axis. And then your dead zone is how much input it's going to ignore before it starts outputting something. So you can play with those, and we can include a link to the get access function and the input manager manual page, and you can kind of see all about that. Does that make sense? Someone else had a question? Yep.
Will we have access to the slides?
Yes, I will post the slides, and we're also going to be adding a final slide with a bunch of documentation links so you can kind of review all of it. Other questions? Okay, we're done. Thank you all for coming.
Don't use this to move object.
Right, okay, so also, this isn't a great way to move player characters. We're going to get into that next time with physics, the physics system and physics-based movement and everything. And that is a huge topic, and so please come to the next workshop, which is next week, not the next actual workshop, which is Friday. Okay, you're good. Thank you.
We may be able to get you rigid body at next workshop.
Yes.
Can we stay here, or is there something that you guys?
Oh yeah, no, you can totally stay here.
Okay.
Your homework.